Hey guys, so what we're going to be doing today is we're going to be mixing up factoring. This is the hardest part of factoring is being able to determine which method we need to use. So that's why we do one day of just mixing it up. So I'm going to lead you guys through the first four, and then you're going to have to do the next eight on your own, and then send me a picture of your work. So let's just review the four that we've talked about so far. We've talked about greatest common factor, which I always refer to as GCF, difference of two squares, which I refer to as dots, factoring a four-term polynomial by grouping, and factoring trinomials by grouping, which is a three-term polynomial. So those are the four methods we've looked at so far. Now, what we're going to do today is we're going to decide which factoring method should be used to factor, either one of those three. And then we're going to explain why we picked that method, and then you're going to do the factoring for it. Why do you need to do that? Because that's sort of how you ask yourself the questions through factoring. You can't just arbitrarily factor. You need to know why you're using those factoring methods, and explaining why you did that is pretty much the whole thing. All right, so here's the first one. The first two I'm going to guide you through. It says 6p minus 72. So every time we attack a factoring problem, your first question should be, is there a GCF? So that should be what you're asking yourself. Is there a greatest common factor between 6 and 72? And the answer is yes. So therefore, I know I'm going to be using GCF here. Okay? Now, why are we using that? Because 6 is in common between both. So that's what we're going to write. Now I'm using my finger today, so it's really fat. I'm going to have to go back and erase this later. All right, so now we're going to factor it. So just remember GCF, we find our common factor, we divide it out, we put it outside a set of parentheses, and then we are going to put the parenthesis here, and then we get, when we divide 6p by 6, we get p. We divide negative 72 by 6, we get negative 12. So that is our binomial factored by GCF. Okay, now we're going to move on to the next one. The next one said, what factoring method are we going to use here? And now our first question is there a GCF between 49x squared and 36? And the answer is no, because there's no x in both terms, and there's no factor that can be divided out of both 49 and 36. So our next factoring method we looked at was dots. Is it a difference of two squares? So if you're not sure, put the 49 in your calculator and the 36 in your calculator. Do the square root of 49 and the square root of 36 and see if they both come out to whole numbers. If they come out to whole numbers, then it's a difference of two squares. And that answer is yes. They're both a difference of two squares because there's a subtraction sign, and both terms are perfect squares. So we're going to use dots for this one. Okay, why? Because there's no GCF, and they are two perfect squares separated. I'm going to put a square there. Separated, SEP, by subtraction. Whoops, that looks like an equal sign. Okay, so now how do we factor a difference of two squares? Well, first you set up your double bubble. You put your plus minus or minus plus, it doesn't matter. And then we square root each term. So the square root of 49x squared is going to be 7x. So that 7x goes in front here and in front here. And then I square root my 36 and I get 6 here and 6 here. So that's how you would factor. You would determine which factoring method it is. If you didn't know that, please pause the video, copy it down, and let's move on to the next two. So the last two we're going to look at here now are these two examples. So first of all, you're going to ask yourself again, is there a GCF between w squared, 8w, and 15 that I could factor out? The answer is no. Is it a difference of two squares? No, because it's a trinomial. So I know I'm going to be using trinomial grouping. Why? Because it's three terms with no GCF. Okay, so how do we factor a trinomial by grouping? We put our 1 in front, we multiply our two terms, we get 15, that's our magic number. We write down it's positive, so we write down our factors of 15, positive 1, positive 15, positive 3, positive 5, negative 1, negative 15, negative 3, negative 5. And we look to see which one is going to add to positive 8, and that would be these two factors. So hopefully by now you're getting better at this. And then what do we do next is we separate our two terms in the middle to 3w, and it's positive and a positive 5w. And we bring down our 15 and we bring down our w squared. Okay, next step, group it. Factor out those GCFs. W is the GCF of these two. So I get W times W plus 3. And then the GCF between these two is going to be 5. So you get positive 5 and then W plus 3. Oops, I'm running into that. Then we bring out our common factor of W plus 3. And then we write our leftovers in the other set of parentheses. W plus 5. Okay, so that's how, that doesn't look like a W. So that would be how you factor a trinomial. And our last one is going to be this one. So again, you ask yourself, is there a GCF between all 4 terms? The answer is no, they don't all have an N. Is there a difference to 2 squares? No, just 2 of them, but that's not enough. There's 4 terms. So now we know we're going to be factoring this by grouping. And why? Because there's no GCF. And there's 4 terms. No GCF. And there are 4 terms. So what I'm going to do is I'm going to group these two, factor out the GCF. The GCF between the first two is n squared, not just n. The biggest one is n squared. So you're going to get n squared times n plus 4. And then I'm going to divide this by -1 and this by -1 because that's all that goes into it. And I'm left with n plus 4. And then my common factor goes in front. N plus 4. My leftovers go inside. N squared minus 1. Now this is the tricky one. How many of you are going to recognize that this is dots? Hopefully you did, and you would remember to break this up to double bubble, plus minus. Square root n squared, get n and n. Square root 1, get 1 and 1. And then bring your n to the 4th down. I'm sorry, your n plus 4 down. So that would be your final answer for this one. Now, those are the really challenging ones. You would never see something like this on the Regents. But again, it's always good to have a challenge. Okay, so pause the video and get this down. I know this is illegible. I apologize. You can always go onto the classroom and print out the answer key that I have as notes to get the notes down that are a little bit more visible to see. But what we're going to do next is I'm going to have you guys, what the heck? Okay, here we go. So now I want you to go back to the worksheet and try the next 8, or 5 through 12, and on your own. And when you've completed those 8, I need you to email me a copy of your work so I could see that what you're doing. Please make sure your name is on both pages. A lot of you are forgetting to do that, and that's just something I need for you to do. And I'm going to try my best and correct your work. If you get it in by 3, if not, I'll post the answer key at that time where you can check your own work at that point before the quiz on Monday. Okay? Which is tomorrow's quiz, which is really not tomorrow. It would be Monday's quiz. Okay? So email me if you have any questions.